So in this, I'm going to talk about like how do you can deploy, extend, and secure OpenClaw agent ecosystem. Okay. So what is the anatomy of a 24 by 7 autonomous operator? The gateway, long running daemon, a position messaging tool booth connecting WhatsApp, Telegram, and a Discord to internal execution environment. Then you have an agent, which is like a runtime, a proactive AI capable of executing real world tasks, triggering emails, manipulating files, and triggering API workflow. So the core value proposition is the complete self-hosted ownership over connections, configuration, and the environment execution. The ecosystem matrix, OpenClaw versus Cloudy Code. So OpenClaw is like fully self-hosted local VPS, whereas the cloud cloud code is cloud and CLE bound. Integration bandwidth, you have a broad native messaging, WhatsApp, Discord, Telegram, Pinchboard. Then you have a narrow terminal stack focus. Then you have a customization, high custom runtime loops, get back memory, external skill. You have a medium optimized for standard coding tasks. While Cloud Code act as a coding assistant in the terminal. OpenClaw operate as a persistent multi-channel autonomous proxy for your digital life. So what is the system requirement and ignition sequence? So you have a prerequisite. You need to have a install the node package. Then you onboard the wizard, which is like OpenClaw onboard install demo. Then you have a network winding, which is recommended for local machine security. And then it requires remote access. So model selection, more powerful model like this thing are indeed more secure against prompt manipulation than a small models, right? So what is the core engine here? So you have identity.md inside your .openclaw, which is like a persona which designs the agent's core self. Example, Nova, OpenClaw Ambassador, Energetic, Curious. Then you have a heartbeat.mb, which is like automatic nerve system, cron-like tasks that run periodically. Then you have a bootstrap.mb, which is like a first thought, which is like everything is executed once on a first boot to gather initial context, then permanently deleted. Then you have a user MD, where the user does your stories, time zone preference, and rolling traction. How do you do a version control mine? The entire OpenClaw directory can be backed up as a Git repository, allowing you to clone your agent exact state across multiple devices. The sense, inbound data routing, external world, WhatsApp, Discord, and a pinchboard. You are authenticated by OpenClaw channel login, gift scan. Then you require the bot token servers, guild ID, and specific channel ID. Then you have a gateway domain, which is like a port 18789, maintains persistent WebSockets and API polling. Then you have an internal execution, which is Node.js OpenClaw runtime. Never expose the agent to unweighted group chats. Elevated execution access combined with the public input is severe vulnerability. What is the hands-on? The anatomy of a skill. So you have a Claw Hub, which is a Claw Hub install, the package manager for external skill. You have an Obsidian Vault querying. You have a Apple Notes via memo clip. You have a Himalaya SMT email generation and a Python. So you have skill.md, which is like a JetBrains Nano. You have a permission read and execute. You have a token cost 24. The configuration is a YML format matter, detailed tools, permissions, token impact, and an API requirement. How do you use this skill? To list the file, use the ls command, the instruction set, markdown, Instagram, natural language, teaching the LLM how to use the underlying script. Skills are essentially prompt injected instructional wrappers that translate natural language request into an executable local code. So the brain, what is the multi-agent context region? Agent is a main and Nova. You have a memory context, which is a casual personal ambassador. You have a capabilities enabled WhatsApp, pin code, Apple Note. You have a status, open workspace, secret, JetBrains Mono. You have an agent which is working, which is a memory context, corporate developer, Git capabilities enabled, GitHub PR action, UML generation, status strictly sandbox inter, separate persona, isolated workspace, distinct tool policy, work stays at work. That what is the threat model? The danger of elevated execution. You have a vector, a malicious actor in a public discourse of attacks the OpenClaw board. The message contains a crafted prompt, ignores previous instruction. Then the execution, because the agent has native terminal, it processes the natural language into an execution commands. Impact complete host and command. OpenClaw operates with the permission of the user running it. If exposed to unweighted external channels, prompt manipulation, such chatbot, hallucination, it is a remote code execution vulnerability. Hosting and security metric. Localhost McAfee friction is less, feature access maximum, full file system, browser high, security critically high, vulnerability, malicious prompt if exposed. Private virtual server, friction is high, require SSH, setup, telescale, feature access medium, no local files, security risk low, isolated environment, disposable server. You have a local Docker sandboxing, friction, feature access high, security is very low. Run OpenClaw security audit deep post installation to identify critical file permission vulnerabilities. Then you have a sandboxing scope. Matrix scope is session. Total isolation is a new container spins up every single session. High compute overhead, maximum security. You have a scope agent, which is a persona isolation. Each designated agent operates its own dedicated container, balances overhead with a clean workspace separation. Then you have a scope share, which is like a resource pooling. All sandbox agents share a single container, minimal overhead, but allows cross-agent file sharing. What is the rule set card? Use tool to deny to block specific tool like executive even within boundaries, and map workspace access to limit read-write capabilities. The complete OpenClaw ecosystem lifecycle. Docker sandbox boundary inbound. A user sends a WhatsApp message, check my developer PR, the router. The message hits the local loopback gateway port 18789, waking the daemon. You have a context allocation. The gateway routes the request to the work agent workspace context, the sandbox boundary. The request crosses an isolated execution boundary, ensuring host system protection. You have a tool execution. The sandbox agent pulls a Python script via ClawHub to safely read local developer files mounted in the system. Then you got a memory update. The outcome is logged back into the Git backed workspace memory, and the result is pipped back out to WhatsApp.